All right, 8 o'clock, time for class. Now, I will admit that this 30-second lag is going to be something to get used to. My name is Adam Buckner. I am an online trainer here at Unity. I used to be doing the live classes when we used Adobe Connect. And get loud mouse clicks. Yeah, it's that keyboard. I do have a nice little keyboard here. It's my little inline slim Apple one. It'll probably still make a lot of noise. We'll see. You'll see how much the Rode Podcaster picks up. So today we are going to make Hat Trick, the fun catch game. It's going to be an introduction to Unity's 2D toolset and a sneak peek at Unity's uGUI. We're going to be using beta software today, not normal for us, but you know, heck, I thought you guys were worth it. So yes, we've got a little peek at uGUI. Not a heck of a lot. We're going to be showing some scores and a restart button, that sort of thing. Go ahead and push this. So here's our. Come on, push it. You can do it. Ah. Okie dokie. How about blank shots up there? There we go. Also, my first experience with Wirecast. So you should be seeing a wonderful little hat. And so we're going to be using Unity's 2D toolset to make the main part of the game, and then we're going to be using Unity's uGUI to go ahead and make the scores. We're going to go ahead and make the time countdown, and then also we will have a game over text. Game over text, and a restart button. So that'll be done in Unity's uGUI. So let's take a look at the stuff that we have. Let me turn these back off again, even though we will be starting a new project. We'll be doing this game from scratch in a brand new project. So let's take a look at the things that we have to work with. We've got some sprites here. We're going to have our hat and our sky, our grass background. We have a bomb. We may not get to the bomb today. We're going to get to at least the catching part. If we can get to the bomb, we will. I'll show you the game in just a second. And then we've got our wonderful bowling ball. Very similar there. We can see our ball and our bowling ball there and our bomb. So the game is very simple when we go ahead and play it. Things fall from the ceiling and we've got to catch them. We want to catch the bowling balls. Yay. And it's randomized. We don't want to catch the falling bombs. Like I said, I'm not sure if we'll get all the way to the falling bombs today, because if you do catch a falling bomb, you lose 2 points. So that's a very simple thing. Count up. You've got a variable amount of time. In this particular demo, we have 30 seconds, but we can set it to be anything that we want it to be and try to get the highest score possible. Now, I mean, it's not a perfect game. There's going to be some things that could be polished up. This is just mostly for explanation, but here it is for you. So let's go ahead and get started. This video is being recorded. It's being recorded either at Twitch or also on ScreenFlow, which I should remember to get started. Speaking of which, sorry about that. And so this will be up on our archives when we're done. Also, I will have an assets folder available on the asset store, so you can download the completed game, all of the assets, and you can go ahead and build this from scratch on your own afterwards. And so when you go ahead and take a look at the archive page, when we're done, you will find a link to the asset store package, which may take me a day or two to get up, but that'll be available for you. So let's go ahead and get started. We want to make this game as dynamic as possible. That's part of the reason that we're going to be using uGUI. One of the things that's nice about uGUI is that notice how our UI goes ahead and can scale with us, so that if we have it for a tablet, and then we can come down and we can make that for a phone. As a matter of fact, don't forget we've got our aspect ratio. So we can do that. We can say, let's make a tablet size. And let's make that fixed resolution of 1024 by 786, 768. And then we can also make another one for phone. Make that 640 by 480. And we can see that our UI is scaling with us automatically. So we will go ahead and show you how that works as well when we get to the UI section. So the very first thing we should do is go ahead and create a brand new project. So let's go to File, and new project. And let's go ahead and set that. Let's go ahead and put that on our desktop. And let's make this new project Catch Game. But one of the important things here is we're going to make a 2D game. And since we're going to go ahead and make a 2D game, we want to go ahead and set up our defaults for 2D. We'll go ahead and take a look at this in the editor. When we set up the defaults for 2D, it does two things. It sets our scene view into 2D mode, and also it sets up our editor for 2D mode. We'll go ahead and take a look at that once we get into the project. So let's go ahead and create our project. And let's not save our scene as we leave it. So now we can see there's the Catch Game. It's being built onto the desktop. And here we are. Let's go ahead and bring that back up to our tablet size. So when we're in 2D mode, it does two things. It sets our scene view into 2D mode. When we're in 3D mode, we can see our world in a 3D view. When we're in 2D mode, we are stuck looking at the XY plane, looking down the Z axis at the scene view. So we can zoom in and zoom out. But we can't rotate the scene. We can find that our rotate keys are now a pan key, because remember, when we're in 2D mode, you can hold down the Alt key and you can rotate around in your scene. When you're in 2D mode, the Alt key is simply another way of panning around in the scene. The other setting that we get over here in Edit, Project Settings Editor, is that we set the default behavior mode of the editor into 2D, and that was when we set up our 2D settings and when we created the project. And that the primary thing that's going to do for us when we're in 2D mode, it means that when we go ahead and import all of our artwork, it's going to be brought in automatically as sprites. So speaking of which, let's go ahead and load our artwork. So let's bring that in. So we've got our sprites. Let's go ahead and just drag that into our project. And we now have a sprites folder, and we can see that when we look at our artwork, it's been brought in as the texture type of sprite rather than as a generic texture. My screen is frozen. Refresh the page. Twitch has been buggy no matter what. This video has been recorded, and it will be viewable later. Yes. And yes, Mike is sitting in and giving me a hand. He's got his big sword there. So let's everyone be polite. The resolution, I'm unclear. Hopefully I don't have anything wrong with my Twitch settings. Mike, are you having issues as well, or are you fine? But I'm going to go ahead and carry on unless this becomes impossible for people to look at. So we've got our sprites that have been brought in, and we can see they've been brought in as the sprite type. And whenever we have something brought in as a sprite type, we're going to see that it also has a child, and that's the sprite itself. And this is a special way of importing our graphics, our images, to be used in our 2D system. If we brought in an image, and we brought in that image as a normal texture, we can just go ahead and change that by changing that texture type to sprite for the 2D and the uGUI. Now, let's go ahead and take a look at our camera. One of the other things that we get when we use those 2D settings, and we've set the editor to its default behavior mode as being 2D, is that the automatic main camera that's created with every scene, as we know that the only game object that we get with a brand new scene is the main camera. We can see that it is an orthographic camera, and its default size is 5. So when we bring in our cameras, we start a brand new scene. We are in 2D mode. Not only do our sprites get brought in as all our sprites get brought in as a sprite, our images get brought in as a sprite, but excuse me, our camera is made orthographic. So let's go ahead and save our scene before we get started. And I'm going to create, I'm going to create a new folder. And I'm going to call that _scenes. Now this is just the way that I like to work. You can save your scenes in any particular folder or structure that you like. I like the underscore so that it sorts my, my scenes folder to the top. And then let's go ahead and save the scene. Save it in _scenes, and let's just simply call this main. So we now have a main scene. Here you can see _scenes, there's main, and then we can see that up in the header bar for those people who aren't aware of this, that we can see our scene, we can see our project, and then we can see our build target, which currently is PC, Mac, and Linux standalone. So we've we're going to pick a general size, which we did before in our game. We're going to pick sort of a general tablet size, 1024 by 768. And we've seen our artwork. So let's start setting up the game. So everything is going to be based on the player object, and our player object is going to be the hat. So there's our hat today. So let's just simply drag that hat into the hierarchy, and there it is in the middle of our scene. It's going to come in when we bring them in this way. If we drag it into the hierarchy directly, it's going to come in at origin at 0, 0, 0. Even though our scene view is in 3D space, we're going to be sort of throwing out that Z in most cases today and just simply dealing with the XY plane. And when we look at the game object, the other important thing to look at is that we're rendering this object, but we're rendering it with a sprite renderer. Since this is a 2D object and we've got a sprite as our image, we're going to be using the sprite renderer. And the sprite renderer is very similar to the mesh renderer, but it is not exactly the same. So when we're dealing with 2D and we're dealing with 2D sprites, we're going to be dealing with a sprite renderer rather than that mesh renderer. So for ease of coding today, we're going to leave our hat here at origin. So it's going to be centered on X, Y, and Z at 0. And so we want our hat at that bottom, sort of in the bottom half, bottom third of the screen. And since we don't want to move the hat, you know, all things are relative, so let's go ahead and move our camera. So let's go ahead and grab that camera and move it up on the y-axis until that hat is somewhere down there at the bottom of our screen. Maybe a little bit further. What looks good? Let's just make that a clean 3. So let's move that up by 3 units. And now let's go ahead and add a background to that scene. So let's go ahead and grab our sky, drop that into the scene. So a couple of things that we see here. The first one is scale is all right. Oh, bother. I kind of blew that one. That should be at 100. Unity's too good. It remembers things. The standard pixels to units on Sky is 100. That's very interesting. A different project, but it has remembered that that has coming in at 100. So there we go. The standard pixels to units, which is how many pixels on our image, is going to be displayed in one Unity unit. By default, when we bring in our our graphics, is going to be pixel to unit of 100, and so the sky is there. Should be a pixel to unit of 100 if we were by default. That must have just held over from the last time we did this project, when I did it myself. So the sky isn't placed correctly. The sky is big, it's out of scale, and we don't see the hat at all. So scale, there's two ways to deal with scale, and one is to simply change that the transform scale. We can change the X and Y transform and make it smaller. So if we want it to be half sized, we can just say, let's scale it down by half. Bring it down to smaller, more reasonable size, makes it feel better for our game. On the other hand, we could leave our scale there uniformly at 1s all the way through, scale of 1, 1, 1, and we can re-import our sky. And we can re-import that sky with a pixel to unit of 200. And if we think about it, we're doubling this number, so we're saying we want 200 pixels on our original artwork to equal 1 Unity unit in the scene. So when we bring that in, our sky is now half the size. And so my feeling is that if you're going to bring in something that is going to be uniformly used throughout the entire game at a particular size, to go ahead and leave that scale at 1 to 1 and use your pixels to units to scale it to the appropriate scale for your game. It's a little bit low, so let's go ahead and lift this up as well, so we can just change our transform here, transform Y, bring that up till it fits. I sort of like to have nice round numbers, so let's make that 3, so it's there in front of our camera. Our camera is up by 3 units, and so our sky is as well. But where's our hat? Our hat is missing. If we look at this take a look at our scene view, and then we go ahead and we look at this in 3D view, we still can't see our hat. The hat's completely gone. We could grab that hat and move it off the Z plane. Oh, there it is. There's our hat in 3D space. And we could, if we wanted to, try to sort all of our items in Z space and Z depth to the camera. So the things we want to see in front, we actually physically move closer to the camera. Things we want farther away, we push farther away from the camera. And we stack things up kind of like in a traditional animation environment, with cells where the closest cell is on top, the farthest, with backgrounds are farthest away. Unity, on the other hand, gives us a much more powerful tool. So we can go ahead and leave that at origin, and we can use sorting layers. Sorting layers are Unity's way of being able to literally sort our layers. We can create sorting layers, we can adjust the depth of the sorting layers, and not have to worry about moving our artwork off of that Z equals 0 location. So let's go ahead and use add sorting layer, and this will bring up the tags and layers in the inspector. If you want to go directly, you can also go over here to the project settings to tags and layers, and that'll bring it up as well. And currently we don't have any layers beyond default. There will always be a default sorting layer, and you won't be able to change its name. You also won't be able to delete it, but we can add new layers. So let's go ahead and add 2 new layers. Let's go ahead and add a background layer, and let's go ahead and add a foreground layer. And like the layers, the normal layers that we have when dealing with our game, sorting layers are not assigned at this stage. We're simply in the tags and layers settings window. So we'll need to go back to our sky, and we'll need to go ahead and assign that to the background, and then we'll need to assign our hat to the foreground. And we can now see that it pops up. Even though we are in 3D space, all on that same Z depth, and there's no Z fighting involved, we're using the 2D system to pick the render order. Now, if we want to go ahead and change the render order, and we're in the tags and layers window, that's simply by adjusting the order of the layers here in the settings window, and it will go from top to bottom, back to front. So layer 0 in this case, the default will be back. Layer 1 background, then the foreground. And the names that we have here, the index number, layer 0, layer 2, and layer 1, are just for identifying which layer we're looking at, and don't have a bearing. It's the order in which we sort them here that makes a difference. So let's go ahead and return to our game view. Bing! So there's our hat. Let's go ahead and add a ground layer for visual interest, something for the hat to rest on. Now, this is going to be a visual clue only. It's not going to have actually any physical bearing on the game. And for that, today, we're going to go ahead and use the grass. So let's go ahead and drag in the grass. Let's look at that in our scene view. Let's go back into 2D mode, and let's give our grass a setting of foreground. Okay. Now we've got them both in the foreground. We've got both our hat and our grass in the foreground. But the grass is on top of the hat. What are we going to do with that? Well, that's what order and layer is for. You can change your order and layer to decide which item is going to be in front in that particular layer. So you've got sort of a hierarchy of sorting layers. We've got foreground and background. And now that we've got hat and grass in the foreground layer, we can go ahead and say that the grass is going to be 0 and the hat is going to be 1. So again, order and layer, we're going to bring up the hat in front of the grass. Yeah, that's Wirecast and ScreenFlow. Thank you, Will. Thanks, and thank you, Mike, and thank you, Will, for moderating. Deeply appreciated. Got my multiple screens going on here. So let's go ahead and drag that down. I want to make that even, so let's just go ahead and drag that on the Y. So let's drag it down to about, let's try 1.5 here. Again, nice, good round numbers. And so there we have our grass in place. If we look in the game view, however, it's not fitting side to side, left to right. We've got, again, 2 choices. We could try scaling it till it stretches. It's not too bad. A little bit mushy, kind of destroys Pete's wonderful artwork. On the other hand, our artwork tiles. So we can go ahead and tile our artwork. If you look back at the scene view, we can see that we have the sprite, and we can duplicate that sprite. Command D. And then we can use vertex snapping. This is the same key combination that we have in 3D View. You can hold down the V key, and then you can pick, oops, good morning, hold down the V key. Let's move that, hold down the V key, there we go, snap. And then duplicate that again, hold down the V key, and snap that there. So now in our game view, we've got tileable grass that completely lines up with itself. Now, the sky, to me, again, looks a bit low at this point, and we've now put in a little tiny border with that grass at the bottom. So I think I'm going to drag that sky up a little higher. So let's see how far we can go before we see a little margin. So somewhere in there, maybe 4.75. Bring those clouds sort of up back into the sky a little bit. Hearthstone was made in Unity. It is. I don't believe it's... Yeah, Hearthstone is a Unity game. So let's clean up the scene a little bit. Let's create a new game object. Let's call this one ground. And I'm going to go ahead and reset that transform. And then I'm going to drag the grass sprites there into the ground there. Just to give us a little bit clean, a little bit of a cleaner hierarchy. So we've got our player object. Our player object is the hat, and we need to get our player object moving under our control. So before we write any scripts, let's get that hat game object set up. We're going to need to add some components to that game object so that we can push it around with our scripting. So the first thing that we want to do is take that hat and we want to add a rigid body 2D. Now this is an analogous component. It's very similar to the rigid body that does 3D physics, but the rigid body 2D engages the 2D physics engine. And since we're dealing with a 2D game, we want to be dealing with the 2D physics engine. And it's nice to know that the two physics engines are very similar. You can have them both in the same scene. However, 2D physics and 3D physics do not interact with each other. So we can't use, in this case, a normal 3D rigid body. So we want to add component. We want to go to physics 2D. And we want to add a rigid body 2D. And so this will make, excuse my throat today. So this will use a rigid body 2D. And like the rigid body, we want to set this one to be is kinematic. We're going to be moving this hat, and we're going to be moving this hat in a very arcade way. So we don't want it to respond to gravity. We want it to respond to the scripting that we're going to go ahead and push to it. So we're also going to be adding colliders to it, and we're going to be moving that collider. So what we want to do in this case is have a kinematic rigid body that we can push around, and keep our performance relatively high in this case. Because if we were moving that that game object around with a collider on it, we would be updating that collider. Would be updating all of the colliders in the scene. We should be making sure that we mark our rigid bodies as is kinematic unless we're moving them with physics forces or we don't have a collider on it. Now we can script the controls, that we can script the controls to that rigid body, and we can use this rigid body to move our hat around in the game. So let's go ahead and start scripting to the hat. So let's create a new folder to hold our scripts, and let's call this scripts. And let's go ahead and add a new component to the hat, and we can do that with the add component menu as well. And we're going to add a new script. And we're going to call this one hat controller. So there's our hat controller. It's being dumped into the root, so let's go ahead and put that into our scripts folder. And then let's go ahead and double click that, and it'll load it into MonoDevelop. We'll get to that in a bit. We're pushing on, and we're probably, my guess is that it's not going as fast as I wanted it to go, so we'll drag a little bit. Or break this into two sessions. We'll go ahead and take a look and see how that's going to work. But yes, we will be getting to uGUI. We showed that off at the beginning, and we'll get that towards the end. So we're going to use an approach with this script that can work with both mobiles and keyboard and mice setups. So as opposed to using the input manager to simply look at input axes and to look at the mouse pointer and that sort of thing, we're going to, this project will still find the pointer, but it's going to be either the finger or the mouse on the screen, and we're going to translate that from screen space into world space in the game. We're also going to clamp this hat within the screen to keep it from leaving the game area. Now, there are sort of three main spaces that we can deal with, and we'll sort of take a look at this in passing as we move forward. There's screen space, which is defined by pixels, on the pixels of the screen that we see. There's viewport space, which is the size of the viewport, starting both of these at the lower left and going to the upper right. But the difference between screen space and viewport space is that screen space is in pixels and viewport space is simply a normalized value. And we need to translate our position on the screen into world space, to be able to move our hat and clamp our hat into that game area. So because we're translating between screen space and into world space, the first and most important item that we're going to need in this script is the camera. So let's go ahead and make a public reference to our camera, and that's going to be a public camera as the type, and let's just call it cam. And we can set this, but we're also looking for the main camera, so we can write a little bit of code that says if our cam is the same as null, then what we want to do is say our cam is going to be the same as, is going to be equal to the camera dot main. So this makes it optional. We can go ahead and assign whatever camera we want, but if we haven't picked a specific camera in our game, we'll go ahead and use the main camera automatically. Next, we want to find the pointer and attach the hat to the pointer. And since we're going to be doing this and then using it to move the rigid body, that rigid body 2D around, we don't want to be doing this in update. We want to be doing this in fixed update. So let's go ahead and change our script from update to fixed update. And you should note that fixed update, as opposed to being called once per frame, is called once per physics time step. And that can be set in the physics settings. So what do we need to do? We need to find our raw position of our pointer. And that is going to be a vector 3. No, it's not. It's going to be some vertical wrap. Let's try that again. It's going to be a vector 3. There we go. So it's going to be a vector 3. And let's go ahead and call this our raw position. That's if I can actually type and code with a giant microphone in my face. Let's see if I can move that a little bit further away. Zoom, please. All right. Let's see if I can do that. I wish I could. Do we know the zoom level? View. Command plus. It's not loving me with my command plus. There we go. Are you going to do that again? No, it seems to only work from the view. There we go. Okay. Do it this way a couple of times. There we go. So we've got our camera, and then we've got our raw position. This is where we're going to get and translate our pointer from. So if we go ahead and look at the camera, and there is a shortcut key to look at the documentation. And yeah, I tried with command with mouse as well. And that just seems to be, for whatever reason, I'm not getting mono develop. And remember, we're using some beta software today so we can show you off to uGUI, so this may be an issue with that. But it seems to today only want to work when I'm selecting it from the menu. So if we take a look at camera, and we hold down the command or control key and hit the single quote button, we're going to get the documentation. And what I want to show you down here is that there are a number of different ways to translate our screen space, our world space, and our viewport space. And those are all in here. Whoops, come here. Including raise, So we've got these three spaces, the world space, the viewport space, and the screen space, and we can translate them back and forth using very simple functions that you can find in the camera class. So what we want to do is be able to take a point on the screen in screen space and find a world point to that, and that is screen to world point. So let's go ahead and write the code that we need, and that is our vector3 raw position is going to be equal to our camera, or cam, and then we want to get a screen to world point. And what do we want to change? We want to change our input dot mouse position. Now this also cheekily will work on most mobile devices as well. I think it works on everything except for Windows. Some of the Windows Phone. So the input mouse position will also be the same in those cases as our touch 0. So there's a certain point where on most devices you'll be able to use this code directly on a mobile device. So we have a raw position, but we only want the x-axis because we've got in our game, don't forget, we've got our hat sitting there. And it's going to be staying on the y and z-axis at 0. But we want to find the x-axis that we're moving for our pointer. So we're going to simply say new line, a new vector3 called target position. And that's going to be equal to a new vector3. And that is our raw position x. And then zeros for the rest. And we need to apply this now to the rigid body, our rigid body 2D. So we need to find a way to get this to our rigid body 2D. And if we go ahead and look at that in the documentation as well, we can see that the rigid body 2D has a number of functions that we can use to move it. Move position. Ooh, it should be. Well, we'll just go ahead and write that. I was going to show off the documentation, but I don't see it right there. So rigid body 2D.move position. And then we can go ahead and move it to our target position. Target position. Let's go ahead and fix that. Make it look nice. Okay, so we've got our vector3, our target position, and then we take our rigid body 2D and we do a move position on it to our target position. So it's going to stay at y equals 0, x equals 0, and we'll use our raw position, or y equals 0, z equals 0, and we'll use our raw position x to move our hat. So let's save this. Let's come back to Unity, check the console for errors, and luckily we don't see any. Let's go ahead and save, and let's go ahead and play. And now you can see the hat is going to move where our cursor moves. It will also go ahead and move completely off screen, which is not what we need. So now we need to find a way to clamp that hat and keep it inside the game area. So coming back to our script, let's go ahead and create a new private float. That's a private float, and it's going to be the max width of our game area. So this is not going to be in screen space again, but this is going to be world space. So we need to find the boundaries of the game in world space. So we need the camera again to determine that. We need to use the camera to determine our total game area. Otherwise, how much does the camera actually see? We do this by finding a point on the edge of the screen in screen space and translating that into world space. And we use this point at the border as our border or boundary. And we can find that size of screen space using the screen class. If we look at screen, there's a screen height and a screen width, which we can get from the camera. So we can, in start, and we only need to do this once. We only need to find our border once. So in start, we can say our vector3, the upper corner of the play area, is going to be a new vector 3. And that's going to be made out of our screen width, our screen height, and 0. And this is simplified somewhat because we are dealing with an orthographic camera, so we don't really need to know what our Z depth is away from the camera. If we were dealing with a perspective camera, that's like a pyramid with the top cut off. So the farther you get away from the camera is extremely different as to where you are in world space. But in this case, we can simply use 0, since everything is playing out in an orthographic camera. Then when we're mostly looking for that screen width. We could honestly probably get the same information here from simply using screen width, and we could use the edge border at 0. So we could use screen width 0, 0, but in this case, we want to find the upper corner. I'm going to choose to find the upper corner, so we're going to use screen width and screen height. We're going to be doing pretty much the same thing that we used to find our pointer. But we want to find this particular corner pixel point. So let's go ahead and copy that raw position and paste that in. And we want to change input mouse position to upper corner. And then we can make our max width equal to our, well, then we want to make this target width as well. I'll change that to target width. So our upper corner is screen width, screen height. Our target width is that screen to world point of the upper corner. And our max width is going to be our target width. Oops. Target width dot x. So now we need to clamp the hat into that area. So let's write float target width equal to mathf. And if you don't know what mathf is, you should look that up in the documentation. It's a very useful class of a whole, or it's actually, I think it's a struct, of a whole bunch of useful basic math functions. Like sine, cosine, min, max, round to int. So we're going to be using this to clamp the position. So we have mathf.clamp. And what do we want to clamp? We want to clamp our target position .x. So the target position .x, and we want to make it between minus max width and max width. Now, this works primarily because the way that we have set up our scene, everything is centered on the zero axis, x, y, and z. And so we're looking at the x-axis. We know that the max width in one direction from center point is going to be max width. So we can take our target position and clamp it from the negative max width to the positive max width. And then we can set our target position. Our target position gets adjusted. And our target position is going to be equal to our new vector 3, target width, target position dot y, and target position dot z. All right, so let's go ahead and walk through this total code. So vector 3 raw position, so we get our raw position, we get our target position, and then we take our target width, and we're going to go ahead and clamp our target position between max width, target position x and max width left and right. And then we update our target position with our new vector 3, and then we're saying that the x is going to be target position, and then we maintain that original target position y and that original target position z. And then we go ahead and do our move just as we had done before. So we come here, and we go ahead and we hit play. And now we're clamped to the edge, because as that cursor goes beyond our max width, that value is set to the equivalent of max width. However, since we're dealing also, again, with a center point, the origin of the hat is in the middle, the hat halfway leaves the screen. So now we need to take into account the width of the hat. So what we need to do here is look at the renderer, because we want to do this as automatically and as dynamically as possible. And The one thing that that knows its size is the renderer. The renderer knows the size of the item that it's rendering. So what we can do is add, after our corner position, we can say our hat width, make a float called hat width, and it's going to be equal to the renderer. Now the renderer has bounds, which is the maximum size of the image that's being rendered, and so that's bounds. And what we want to find out is the extents of those bounds. So extents is half of the total width from left to right. It's the extents, and we want to find it along the x-axis. So what we can find here is the hat's width by asking the renderer to look at its bounds to tell us the extents on the x-axis. And then we can say we want our max width is going to be equal to target width minus our hat width. And now when we go ahead and play, it's clamping it exactly to the edge, including the hat. So let's drop some objects to catch. So first, a little setup. We're going to be taking our bowling ball, and we need to be able to set this up as a physical object, and then we need to save it as a prefab so we can drop it from the top of the game. So let's go ahead and open the scene view. And then let's go ahead and look at our sprites. Let's take our bowling ball and drop that into the scene. So we now have a bowling ball to catch that's in our scene. And let's add this to our foreground layer. So let's our bowling ball. Let's go ahead and add that to our foreground layer. And we need to bring it in front of the hat. And remember, our hat is in layer 1. So our bowling ball needs to be in layer 2. So there we've got our bowling ball. And it needs to be a physical object. So we need to set this up with a couple of additional components here. We're going to need a physics 2D, rigid body 2D. And we do not want this one to be is kinematic. We want to have it be able to drop under the forces of gravity. We're going to use the physical forces in the 2D engine to be able to bring that ball down on top of us. And the other thing we need to do is be able to have it collide in the scene. So let's give it physics 2D. Let's give it a circle collider. And now if we look at it carefully, we can see that that circle collider is automatically sized to the circle. So the circle collider is optimized for round objects, and it's ignoring the white space, and it's going ahead and it automatically matches that circle collider around to the outside of our bowling ball. So we now have a physics object. The other thing that we would like to have is that we want a material. So let's create a new folder, and let's call this one physics material. And then let's create inside that folder a new physics material 2D. And let's just call this our bowling ball. And I wanted to give it some additional friction. What I found when I was running this game is that even though bowling balls are themselves relatively slippery and relatively smooth, it was a little bit too slidey, and I wanted to give it a little bit more friction. So I'm just throwing a bunch of friction there into that physics material. And the way the physics material goes is onto the collider. So let's go ahead and grab that physics material and drag that into the collider. So we now have our rigid body 2D. We have a circle collider with a physics 2D material on it. So we now have a little physical ball. Let's save this. Let's back out a little bit, and let's just sort of drag it up there a ways, and let's hit save, and let's hit play. And we can see that our ball drops. How convenient. Will there be a particle system that will instance when the ball collides with a trigger? Eventually there will be one on the bomb, but we're not going to do that at this point on the bowling ball, partly to keep things moving. But you can do that. You can find that contact point just as you do in 3D, and you can go ahead and emit a particle at particle system at that point. So now let's go ahead and create a prefabs folder. Call it prefabs. And then let's go ahead and put that bowling ball in it. So we've now created a bowling ball. Just for me, I like to go ahead and zero those out, because even though it's reset up here, we're going to leave this instance in the scene to go ahead and do some testing with it. So we're going to now need something to catch the ball with. So let's add an edge collider to the hat. So if we take a look at the hat, let's focus in on the hat. We're going to add a physics 2D, and we're going to add an edge collider. And the edge collider is what we're going to be using to collide with the ball. So let's go ahead and move that up. I would like it to be above my my scripts. I like to have my scripts at the bottom. And then to edit these, there is a little edit button. And when the edit button, that's a little bit hard to see. I'm going to turn off the background, the sky and the ground now, just so that we can have a better chance of seeing what we're doing here. So let's go ahead and look at the hat. Let's hit the edit button. And now we can see that there's a little point that's moving across. If we do it at the end, we're simply moving the line around. If we take it in the middle, we're adding a point to that edge collider. So let's go ahead and set this down here to the edges. Let's probably actually, I want to put this down here, believe it or not, because you expand from the middle. So let's go ahead and drag these out, drag out a couple of these. And, whoops, grab the wrong one. Thank you. Let's go ahead and drag that across there. Make it simple. Now we'll drag this across the edge. Okay, so we have the rough shape of the hat. So if we bump into something on the sides, it's not going to look terrible. And then we also want the rough shape of the inside. For catching those balls as they come down. So now if we hit save, let's bring back the ground, and let's bring back the sky. Let's back out a little bit, and let's go ahead and hit play. Oh, and let's catch the ball this time. Bonk. We have a problem. And we need we've got our sprite for our hat, but we need the back brim behind the ball. But we need the rest of the hat in front of the ball. Because if we look at this in our game view, or in our scene view, excuse me, and we look at the hat, we can see that it's resting there in on the collider. But this isn't going to work unless we can somehow do something with the sprite. So let's go ahead and take a look at our hat sprite. And let's take a look at that in Photoshop. Luckily, we've pre-cut our hat. So we have a front layer and a back layer. So let's go ahead and save these out. Let's go ahead and save that back layer to our catch game, to our assets, to our sprites, and let's call this hat back. And then save this one to our hat front. Come back to Unity, and it's going to import these, and they're going to be imported as sprites. So the first thing we need to do is take our hat, and then let's go ahead and replace our total hat with our hat back. And so this is going to be the layer with the collider, and this is going to be the layer that's behind the ball. And it's going to stay with all of our logic, and it's going to stay on that same order and layer of 1. So then let's add our hat front as a child of our hat. And then it's a new object, so we're going to need to give it that foreground. And we're also going to need to give it an order and layer that is going to be higher than our bowling ball. Our bowling ball is at 2, so let's go ahead and put our hat at 3. Now if we hit save, and we hit play, we can see that the ball falls into the hat. And if we go ahead and look at that in the scene view, we can see that it's hiding in there. inside the hat. But speaking of hiding inside the hat, we have a bit of a problem, which is we don't want to keep all of the balls in the hat. We actually need to destroy them when we'll want to destroy them once they're inside the hat. For that, we need another collider. So let's get out of play mode. Let's take that, our hat game object, and let's add a new physics2D and a new edge collider 2D. And let's move that up. So I've got them next to each other. And then again, let's turn off the sky and the grass so we can see better the green lines there. And then what we want to do is we want to edit our collider down here, and we want to bring that to the bottom, right near the bottom, but inside our collision here. Also note that our line, that we didn't close this this edge. The outside collision is not closed. Doesn't close up because line colliders, edge colliders cannot line up. They have to be an open line. So there we've got our bottom destruction trigger, and this is going to be a trigger collider. So we're going to make sure that we pick is trigger is true. So now we need to script to this edge collider that we've made. And what we want to do is write a generic script that can work in many different cases, because we're going to find another use for this as well. So let's go ahead and add a new component. Oops, excuse me. Add new script. And this script is going to be called destroy on contact. And then let's file that away in our scripts folder and then open that up for editing. Two seconds. Okay, so we've got our destroy on contact script, and this destroy on contact is going to be a very, very simple script. Let's remove all of the sample code. We don't need any of the sample code there. And what we simply need to say is void on, now this is going to look similar on trigger enter, but this is 2D physics. And if we just simply wrote an on trigger enter script, it would be looking for the 3D physics engine, and it wouldn't work in this case. So what we want is on trigger enter 2D. So void on trigger enter 2D, and then again, very similar setup to our on trigger enter calls for our 3D physics. We are looking for a collider, but a collider 2D. And then we'll also call this one other. And then when we have a collision with another collider, we want to destroy the other dot game object. Oops, why using? Now this is a reusable script, and then we will find a place. There's another place that we're going to go ahead and use this. So let's come back to Unity and check our console. And now, when we turn back on our ground, and we turn back on our sky, we hit save, we hit play, we catch the ball, and it's destroyed. The other place that we want to use this is on a new game object called destroyer. And this will catch all of the game objects that fall out of the game. So anything that we don't catch will fall out of the game and will be destroyed. So we want to create on this a Physics2D edge collider and make that a trigger. And we also want to add our component. We want to add a script. We want to add our destroy on contact script. Let's go ahead and edit that. And where we want to put this actually is up here and up here, because this we will use to surround our scene. So anything that pops out, and it is possible, since you can punch these pretty far, that it may go up a little bit. So let's just go ahead and stretch those out. So let's hit save. Let's go ahead and hit play. And we can see that if we miss the ball, it hits the destroyer object and it's destroyed. Now, the next step is spawning. But I have a small confession to make, which is that I completely underestimated how long this was going to take. I haven't actually run this because I made the quick game and I wanted to do it. We have run to our hour. We're at 9 o'clock here in the UK. And I have this feeling I should schedule the rest of this for later this week.